Modern technology has a need for advanced material science, and that's something that we all experience in our daily life, with our electronic devices, our phones, our computers, and we often don't realize how important is the research on the materials that make all these components of this electronics, and not only electronics, but you can think about biomedical devices or transportation, or all of the technological aspect of our life is dominated by materials. And that's been like that for, I would say, since the beginning of time in a way, because if you think about going from the Bronze Age to from the Iron Age to the Bronze Age was related to a material, or the importance of discovery of new tools made of particular materials has advanced humanity in all its history. Right now we are at a stage where we need more and more materials that can do very specialized things. So we need a particular material to make my iPhone work as I want it to work, or my GPS in the car to work as I want it to work. And many of these materials are not so common. We've been spoiled by silicon technology. So silicon is another element, another material that we wouldn't have all the electronic revolution if we didn't have silicon. But silicon is getting kind of the end of the line of its applicability in many things that we want to have faster response from all of these devices. And so we are going towards the use of very specialized materials that are rare, that might be difficult to handle. They might be economically unviable because they can be mined only in some parts of the world where you might not want to go and mine, or it might be very expensive to get them. And so one of the critical problems that we are facing as a community of material science and engineers and physicists and chemists is to try to develop alternatives to these materials that can work as well as the original material that was thought of, but they are cheaper, they are environmentally friendly, they are readily available. So, that's the dream that we have, that we will be able to achieve these goals. And clearly, this search, that goes into this development of new systems and the finding of new materials, it's the search that we are talking about as a community, and in particular as my research group and within the collaborations that we are in. And in particular, this collaboration is called AFLOW, this consortium of universities that is working towards the development and discovery of new materials using computational techniques. And that leads to this other aspect that is very important in our research and the research in my group and in our consortium, that is, we are not experimentalists. We are all theoretical physicists and chemists and engineers that use computational techniques, and so advanced theories that have been translated into very complicated computer programs to find and characterize these materials that might be the alternative for the future application. Of course, this is a process that generates an amount of data that is enormous. And in particular, one of our goals as a consortium is the development and sustain improvement of databases of material properties that become a tool for discovery. So the idea is, we have the periodic table. We can take any atom from the periodic table and associate to any other atom, or any two atoms and any two elements without two elements, and we can create all the possible combinations of materials in principle that we can think of, although they might not exist. And of all these combinations, we calculate and store in a database all the properties. And this is something that it's hundreds of thousands of calculations, hundreds of thousands of set of data that we are generating and that are being generating as we speak. So we always have computers that generate this data. Then the next step is, what do we do with all this data? Because the data by itself is not knowledge. It's numbers that occupy a space in a hard drive. To extract knowledge from this data, we have to, first of all, identify what is the problem that we want to solve, and then look for, in the database, using advanced algorithm, computer science problems, if you wish, to find those elements that match our requirements. And this we call the search for the new materials. And this search might give you unexpected results. Like you might discover new sets of materials that you didn't think of before as possible application for a given device that have actually the properties that you're looking for, and they might be cheaper, or they might be not toxic, and they might be readily available for you to use. We have examples of this procedures. We have published papers over the years where we discover new classes of materials based on this kind of searches on big data analysis.